Welcome everybody to another online session of Mr. Zukowski's virtual geometry class. Today we're talking about congruent triangles. We're in chapter 4, section 3. By the end of this lesson, you're going to be able to answer the following questions. Can I name and use corresponding parts of congruent polygons? Can I prove triangles congruent using the definition of congruence? And here's where we're going to start. Head over to Canvas. I have a link here. It's under chapter 4, section 3. You're going to explore a little bit. You're going to explore what's called corresponding parts of congruent triangles. And under here, you can view this worksheet or you can download it. I recommend downloading, but viewing should be fine for this one. I want you to, once this loads, I want you to pause this video. I want you to interact with these points and start to see if you can see some type of relationship, some type of pattern going on here. Use corresponding parts to identify the congruent triangles. You're going to move this slider down. It's going to reveal some things to you. And then we're going to bring it back together and kind of review what you just found out. So pause it. Come on back. Welcome back. All right, so what happened here? Notice these triangles, no matter how you move them. Oh, what the? Yeah, just ignore that. Sorry. Notice that as you move these points, the triangles always stay, they match up perfectly with one another. You can stack one right on top of the other. And that's going to be the whole basis of what we're learning today, because as triangles are congruent, all of their parts are going to match. But which parts? The parts that correspond to each other. See, in this case, the blue with the blue, the red with the red, the green with the green, all those angles and all those sides that correspond, that match right over the top of each other, they're going to be congruent. It's our big rule of the day. So the one in the sides in blue, the sides in red, the sides in green, no matter how you move these, they all are going to stay correspondingly congruent. Catchphrase. All right, next part. The angles, same story. So the red angles, the blue angles, the green angles, and oh my. They are all going to be congruent to each other. And then here is going to be the big key for how you are going to be able to relate figures to just written expressions. So if all I did was write this right here, that triangle VAR and triangle MTG, if I write that those are congruent, so I put that funny little squiggly equal sign in there, a little equal sign that has some spaghetti on top of it, those are going to have all of these parts in this order. So like V is in front, so V is going to match M, so angle V is going to match angle M, and you can see that right here. So angle AVR is going to match angle TMG, sorry. Or if you pick these two letters in a row, VA and MT, the first two letters of each written triangle. So I better do something about this. Keep the current color scheme at SP and get it my computer. Don't show that again. Thank you. Okay, so VA and MT go right here. AV and TM. So notice the order they picked them in. They went second to first. AV. They went second to first, TM. So those are both 4 over here. It's going to be so key for today. So if that makes sense, you're going to be in great shape. I'm not going to worry about that right now. Just shows that you can move this in all sorts of ways. It doesn't matter what kind of orientation it's going to be in. The corresponding parts of these triangles are going to be congruent as long as the triangles themselves are congruent. So I gave you a note sheet. Here's what your note sheet looks like today. There's your first example basically, but this gives us the rule. We're going to use this model and we're going to write the rule down that two polygons are congruent if and only if, and here's what you're going to write down. They are congruent if and only if, sorry, I hope this doesn't make you too nauseous. If and only if their corresponding parts are congruent. So this works forward and backwards. If all 6 parts of the triangles match, if they're all congruent, if all the corresponding angles are congruent and all the corresponding sides are congruent, then those triangles are congruent. Or you can say that backwards. If the triangles are congruent, notice the color coding here, how key that is. The red ones, the 2 letters that are written first, those angles are going to be congruent. the light blue ones here, B and J, because they're in the middle, those angles are going to match. They're going to be congruent. They correspond to each other, so therefore they're going to be congruent. And then the way it's written, C corresponds to K. So angle C is going to be congruent to angle K. And then the sides are going to work that way too. If you pick the first two in that order, letter 1, letter 2, letter 1, letter 2, AB is going to be congruent to HJ. The second two letters, so second and third letters, BC and JK, those are going to be congruent. A and C, H and K. That's the first and the third, first and the third. See the pattern going on there? Great. Moving along. If you need to pause that, feel free. So first question. Show that the polygons are congruent by identifying all the congruent corresponding parts, then write a congruent statement. So they've drawn it in such a way that you can clearly see that these two pentagons, these five-sided figures, are going to correspond to each other. They're going to overlap. You can take one and you can put it onto the other so that all their parts are going to match. You have 5 angles here to write. You have 5 sides here to write. Feel free to pause this so that you can take the time to try to write those in on your own if you think you got it. Otherwise, stick with me. So the 5 angles that match are written like so. Angle A and R, angle B and T, angle C and P, angle D and S, and angle E and Q. Those are congruent. They correspond to each other, so they are congruent. And then the sides, you can reverse the letters here. So like instead of writing AB, you could write BA. But if you do that, I would recommend you to reverse the letters over here too. So that'd be, instead of RT, it'd be TR. But it's only this pair that you're going to write. So it has to be A and B, and R and T are going to be congruent to each other. So then you have segments BC and TP, segments CD and PS, segments DE and SQ, and segments EA and QR. So now put all that together and give me the congruence statement. So we pick those 5 letters in a row that are going to match the 5 letters in a row on the other figure. And notice they're not triangles this time, so don't put the triangle symbol in front of it. You can just write the 5 letters. So that's pentagon ABCDE is congruent to pentagon RTPSQ. Question 2. Use corresponding parts of congruent triangles. In the diagram, triangle ITP is congruent to triangle NGO. Find the values of X and Y. So highly recommend you do this. Write down that angle I is going to be congruent to angle N. So if I is 65, that means N is going to be 65. If T is 75, then if T is the second letter, then the second letter G, that angle also has to be 75. All right. But the one that's really going to help us is O. Because what does O match up with? What does O correspond to in triangle NGO? What does it correspond to in triangle ITP? Angle P. So if angle P is 40, this whole thing is 40 right here. Then you can look at the, you can go right over here and figure out what you need in this. So that can help you solve for Y. Feel free to go ahead and pause it right now and do that. Now that you have Y, I can use Y and I can plug it into NG. And then I can know that NG, if I go up to this, again, the congruence statement, NG is the first and the second letter of this triangle statement. But over here, the first and the second letter are I and T. So I find I and T over here. I and T is 7.5. So I know NG is going to be congruent to IT. Let's take a look at that work. Oh, CPCTC. Better define that thing. I kind of gave the tip away earlier. So before we go too much further, we better write that down in your notes. What does CPCTC, say that 10 times fast. Go ahead, do it out loud. Freak out your substitute right now. Corresponding parts of congruent triangles are congruent. That's basically what you just said up above, what you had written in your notes already up here. It's saying that if we know that triangles are congruent, so if I know this part, if I know triangles are congruent, well, which I did, because it said 2 triangles are congruent right here, If I know they're congruent, then all their corresponding parts must also be congruent. So I guess I should have highlighted it this way. If you know you have congruent triangles, then the corresponding parts are congruent. CPCTC. We're going to use that quite a bit. All right, so we know 6y minus 14 equals 40. So y has to be 9. Remember, we're going to plug that back in. So we're going to have x minus 2 times 9 now equals 7.5. So x has to be 25.5. Feel free to pause it again if you want to go back and get some here. I went a little fast, sorry. Here's the previous page, so if you hadn't paused that. And then there's the rest of the work. Third angles theorem. So you're going to be writing that in this box right here. If two angles of one triangle are congruent to two angles of a second triangle, so notice C and B, that's two angles of one triangle, are congruent to K and J correspondingly of this second triangle, then the third angles of the triangles must also be congruent. And you know that because if all of these have to add up to 180 and these two are equal, and all these have to add up to 180 and these two are, I'm sorry, not equal, but they are congruent to these corresponding angles right over here, then you know this third angle, whatever it is, has to be equal to this third angle right there. So if angle CK is congruent to if angle C is congruent to angle K, I need to slow down a little bit. I need to take a chill pill. Shouldn't have drank so much coffee right before I recorded this video. And angle B is congruent to angle J. So if we have two congruent angles of two triangles, then angle A, the third angle, has to be congruent to the other third angle, L. Deep breaths. Should get a brown paper bag or something. All right. Example 3. Fancy little picture we have over there. I don't know what that is. The top of a church? Sure. Say that is. A drawing of a tower of a roof. Ah, there we go. There it is composed of congruent triangles, all converging at a point at the top. If angle IJK is congruent to angle IKJ, look at that. It shares some letters there. And the measure of angle IJK is equal to 72. Find the measure of angle JIH. If you think you have an idea, if you want to try it on your own, this is a good time to pause it. Okay, so highlight a few things. Angle IJK, follow them in that order. You can take your highlighter, you can take your pen, go IJK. So we're talking about this angle right here. It's congruent to angle IKJ. So that's angle, this angle right here. I don't want to use one letter, remember? Because if many angles share this same vertex, I don't want to use one letter. I have to use 3 letters to be specific. And angle IJK, so this angle right here, is 72. You can bold that in. You can highlight that on yours if you want. Then find the measure of JIH. JIH. So we're way up there. Well, it already told us earlier that these are congruent triangles. And if you have congruent triangles, CPCTC, if you have congruent triangles, then their corresponding parts are congruent. Well, I do know JIK is congruent to HIJ. Triangle JIK is congruent to HIJ. So if I can figure out what this angle is up at the top here, then I got it. That's the one I'm looking for over there. And I can know that these two angles are congruent, so this is 72 and this is 72. What do the angles of a triangle have to add up to? 180. So I can take 72 and 72 away from 180. So I take it away twice. That'll give me this remaining angle up here. And that corresponds to this top angle up here. So if we have congruent triangles, the corresponding parts are congruent. CPCTC, that whole thingy. All right, so here's the work. That's our congruent statement. The 3 angles within that triangle have to add up to 180. So substitute. You've got 72, 72, but you don't know the third one, so subtract. You should get 36. And since that corresponds to the other triangle, it's going to be 36. Last example here of the different kinds of problems we have. Proofs. Oh, don't you just like it when the proof is so fancy like this? You know, it's formal. It looks like a bow tie. Yeah. No, I don't know if that's going to make it any better for you. So we have to write a 2-column proof, but don't worry. CPCTC, that's what we need to worry about. We need to know that if we have congruent triangles, then all 6 of their parts are going to match. Or, and vice versa. If we can prove that all 6 of these parts are correspondingly congruent, then the triangles themselves have to be congruent. So you're going to have 6. You're going to have to prove to me that all 6 parts of these are congruent. You're going to have to prove to me that each corresponding side is congruent to one another, and each corresponding angle is congruent to one another. So here's what's given. We're given all that stuff up there that's marked in the diagram. So angle L is congruent to angle P. They have equal measures, whatever they are. Side LM is congruent to side PO. So there's LM and PO. That's why they have 1 mark on them, because those two are uniquely equal to each other. LN and PN, those match. Those are congruent. So there's LN with 2 marks. So then, therefore, PN has to have 2 marks. MN has 3 marks. OP has 3 marks. Those are congruent to each other. So now somehow I need to know, I'm missing something. What am I missing? How many sides do I know are congruent? 1, 2, 3. I know 3 sides. That's all 3 sides. We're good to go with sides. So now I have to make angles. Which angles am I missing? All right, so I've got 1 set of angles. I need to somehow use something to prove that the 2 other pairs of angles in here are congruent. And then if all 6 corresponding parts are congruent, then the triangles here, this statement right here, is going to be true. So let's do that. So it is given to us. You got a bunch of great stuff there. Nice little birthday present. Pre-birthday present. Pre-Christmas present. I don't know. It's just a reason to celebrate. It's math. You got to celebrate. What you might not have caught, though, is that angles L, N, M, and P, N, O are vertical. Vertical. What shape do vertical angles make? Go and highlight these. L, N, M, and P, N, O. L, N, M, and P, N, O. If you did it right, you just made an X made by 2 intersecting straight lines. And vertical angles are congruent. So that's how you had to know that these 2 angles are going to match. How do I know the other ones then? If I have 2 pairs of angles already congruent, isn't the 3rd pair congruent? Bet your pencil it is. Yeah, that's right. So the last angle that you didn't mention in there, you can mention is congruent by the 3rd angles theorem. Notice 3 letters, 1 letter. 3 letters, 1 letter. 3 letters, 1 letter. Why did they do that? Because in the picture, N could be this angle, it 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 could be this one, this one, this one, this one, and all sorts, and then it breaks. But there's too many angles to just use 1 letter. But over here, I know exactly which angle I'm talking about. There's only 1 corner right there, M and O. You can use 1 letter if there's only 1 angle drawn. And then the last thing is that now that you know all 6 parts match, so there's 1, 2, okay, let me do this again. 1, 2, 3 sides. Those match. Those correspondingly are congruent. And then 1, 2, 3 angles. 3 angles, 3 sides. And then go back up to the top of your notes. 3 angles, 3 sides. 3 angles, I'm sorry. You know, and close your eyes for a moment in case that's painful. There we go. There it was. Definition of congruent polygons. If all of their angles are correspondingly congruent, so 3 for a triangle, and all of their sides are correspondingly congruent, then the triangles themselves must be congruent. Oops, I gotta go all the way back down again, sorry. There's probably a better way to do it. Oh, yeah, hey-oh. There it was, CPCTC. So that's the thing, corresponding parts of congruent triangles are congruent. Ta-da! Happy Chapter 4-3 Learning Day. If you would like, pause it here. Go check out the Check Your Progress questions that come next. And then I'll reveal the answers to you. So you can pause it. You can try those out. And then otherwise, I have a few IXLs and you have your quiz up there ready for you. So have fun. Dum, 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 dum. Dum, 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 dum. Boo, boo, boo.